Welcome to Mathematics Pro. So today we are going to have this question involving optimization that will enable us to calculate the maximum volume. So given this square, so you can be given a square paper and they want you to create a box that will have a maximum volume, meaning which box can you create with this piece of paper that will give you a maximum volume. So the question here is to look for x. X is the height. So given this, we are going to cut this paper. If we cut this paper to form a box, we need to cut this and this. But the question is, which dimension are we going to cut so that we are going to have a height that will give us a maximum value. So let's get started. So this has been cut already. So if we cut, this will be h, height. So this will be the height of the box. Here as well, we are going to have the height, the same height. So volume, we know that volume of a cuboid is length times width times height. So what is the length of this box? So here is, they gave us this dimension. So this dimension is 30. So we have 30. Since A is a square, so we have 30. So the length will be equals to 30. So 30 minus, we need to cut this, 30 minus h minus h. So 30 minus h minus 8, it means we are going to have minus 2h. And for the width, the same. We have 30. So we need to subtract minus h because this will be cut, minus h minus h. So this will be cut, will be left with only this. So 30 minus h minus h. So the width is going to be equals to 30 minus 2h as well. Now we have the height. So this implies the volume will be equals to length times width times height. So the length is 30 minus 2h, 30 minus 2h times the height. So next we need to expand. So if we expand this, you can see that we are going to have 900, because 30 times 30 is 900, and here is going to give us 60h. We have 60h. So we are going to have minus 60h minus 60h will give us minus 120h plus 2h minus 2h times minus 2h will give us 4h square bracket h. So if we multiply all of these times h, we are going to have v will be equals to 900h minus 120h square plus 4h cube. So let us arrange this. If we arrange this, we are going to have 4 according to power, 4h cube minus 120h square plus 900h. Okay, so we need to, next thing to do is for us to differentiate. So if we look for the derivative, if we look for v prime, so the next step is to differentiate. So if you look for v prime, so we know that when we have n, x, n is the same as, when we have x, n, when we differentiate is the same as n xn minus, we have n minus 1. So this is the formula we use for derivative. So we take this n here and we minus 1. So we are going to apply this formula for differentiation here. So this will give us, if we take this, we are going to have 3 times 4, which is 12. We minus 1 to the power square. Minus, if we do the same to 2, we are going to have, this will give us 240. If we minus 1, we'll be left with h. Plus, if we differentiate this, we are going to have 900. Now the next thing to do is to equate this to be equal to 0. So we are going to have a quadratic equation. So v prime should be equal to 0. So if v prime is equal to 0, we are going to have 12h squared minus 240h plus 900 should be equal to 0. We can factorize before solving this to make things easier. We can factorize 12 out. So if we factorize 12 out, we'll be left with h squared minus 20h plus 75 should be equal to 0. Now we can use quadratic equation. We can use factorization to get the value of h. So h squared minus 20h plus 75. So the essence of this equation is to get the value of that height that will enable us to have the maximum volume. So if we use factorization, we are going to have h. If we think of two numbers that when we add them together, it gives us minus 15, and we multiply them together, it gives us 17. It's going to be minus 15 minus 5 will be equal to 0. So h will be equal to 15, or h equals to 5. Okay, so here at this point, we need to choose one of these. Now ask yourself, if all this dimension is 30, so we can not say that the height of this box is 15. So just imagine that you're going to cut this to be equal to 50. 15 is half. How can you cut half of it to form? So the best thing to do is to choose h. So the value of h should fulfill this condition. So we have this for h. So h is equals to 5. So we are going to choose h. Now that h is 5, so remember our initial dimension here was 30. This length was 30. So now that h is 5, if we want to calculate the length, we'll be involved only with the horizontal lines. So all of it is 30, so this is 5, this is 5, so here we'll be left with 20. If we want to calculate the width, the same, this is 5, vertical line, this is 5, so all of it was 30. So if you minus 5 and 5, will be left with this length will be 20. The width will be 20. So this implies this is the length, this is the width, and the height of the box is 5. H is 5. So if we go back to our equation, so I've written it this is the length, this is the width, and this is the height. So the maximum volume that you can create a box that you can create that will have a maximum volume. So the maximum volume will be equals to length times width times height. So the length is 20 times 20 times 5. So if we multiply this together, we are going to have 2000 centimeter cube. So this is the maximum volume that you can get using this square paper. Not other volume can be greater than 2000. Thanks for watching. Please subscribe.